Hey, it's me. How are you doing? It is, for me, Monday morning, 10 in the morning, and here we are. We need a new lesson today to finish out section 1.4. Couple things. Before we get into that, I got kind of a new different camera angle here, so anytime I have to do something on the computer, you're going to see me going back and forth, but at least this way, I'll close my laptop there. At least this way, like as I'm writing, I can just kind of look up at you there, and that'll be cool. All right, so we are going to finish up lesson 1.4 here. Then Tuesday, you don't have this class. Then Wednesday, oh yeah, you're watching this on Wednesday, aren't you? Sorry, I'm looking at my schedule here that I have for all these classes, but so Monday you watched the video from 7th period, or either that or you were in 7th period. And today you're watching the video to finish lesson 1.4. Okay, then we are finished with e-learning after today. Now, when I say that, I mean we're finished with the whole school being on e-learning. As you probably know, on Thursday, we're starting this hybrid schedule. So just in case there's some confusion about that, which why in the world would there be confusion about that? That's sarcasm, by the way. Totally understand if there's some confusion about it. We teachers are still trying to wrap our minds around it, but we're going to make it work. So on Thursday, if your last name ends with A through K, then with the hybrid schedule, you are in the Avon group. If your last name ends in L through Z, then for the hybrid schedule, you're in the Oriole group. So we got the Avon group and the Oriole group separated by last name. On Thursday and Friday, Thursday's a black day, Friday's a gold day. We are back to the schedule that we've been following all year, right? With the 4 periods a day with the block schedule from 8 o'clock till 2:50. So everybody's following that schedule. However, if you are in the Avon group, meaning your last name ends A through K, then you will be at home all week. So even Thursday and Friday, you're going to be at home doing remote learning. I will have something posted to Schoology for you to do on Thursday or Friday. If you are in the Orioles group, which is last name L through Z, then you will be in school on Thursday and Friday. You're going to be here, and then we're going to switch. We're going to do a black and gold with half the school here and half the school at home. And then for the next 2 days, you switch. So you'll be in school for 2 days and then remote learning for 2 days, and then in school for 2 days and then remote learning for 2 days, because every time you're here is a black and a gold rotation. All right, cool. Moving on. Let's get lesson 1.4 finished here. I am going to figure out a way for everybody to have time to ask questions over homework. So be sure you're doing your homework, especially as we finish lesson 1.4 today. You want to make sure that you are going and doing that assignment. This is definitely the toughest lesson in this chapter. Okay, just pause there. I meant to set a timer, but I forgot to. I don't know how many minutes I've been going here, but we'll say it's been about 5. Okay, moving into lesson 1.4. Let's get this going. And let's see if my camera is focused. Focus camera. Good job. Nicely done. Okay, we were in these applied geometry problems. We finished example 3 and example 4. We've got 2 more of those to do. Then we're going to move on to the motion problems. You see there's 2 on this page and then 2 on the page after that. If I could turn the page, there's 2 more at the end there, and that's it. So we go 1, 2, 3, 4. We've got 6 problems to do. Let's go through these 2 geometry problems. Remember that the idea here is that we are solving problems where you have to do really 2 main things. You have to define a variable and you have to write an equation. That's what this is all about, defining a variable and then writing an equation. Now, solving the equation is part of it too, of course, okay? But all these problems involve you defining a variable and then writing an equation. That defining a variable step gets left out so much, and so we're trying to just teach you not to leave that step out. So the measure of the supplement of an angle is 25 degrees more than 7 times the measure of the angle. We want to know the measure of the angle and its supplement. In case you have forgotten what the supplement of an angle means, we have two words that people get confused a lot. Those words are complement and supplement. Complementary angles have a sum of 90 degrees, while supplementary angles have a sum of 180 degrees. You might have your own way of remembering this. I always just kind of thought of it in alphabetical order, like complement C comes before S, 90 comes before 180. That's just the way I always, remembered it. Or here's another one that I made up. If you get into an argument with somebody and you decide you don't want to be in an argument with them before, like you're over it, then you give them a compliment. And once you give them a compliment, then everything is all right. Get it? 90 degrees is a right angle. I know you're sitting at home laughing right now. Make sure you show your parents that one too. If you're in an argument with someone, you give them a compliment, then everything is all right. I don't know. I think it works. Okay, so supplement means they add up to 180. So if we draw a picture here, here are two supplementary angles. And let me just define a variable for one of the angles. It says the supplement is 25 more than 7 times. So the original angle is the small one. Let's call that x. The supplementary angle is 25 more than 7 times the original angle. So if I take 7 times the original angle and add 25, that gets me that complement or the supplementary angle. Okay, to the nearest hundredth, what's the measure of the angle? So now we're like, well, what the heck do we do with these things? Well, what we do with them is we use the fact that they are supplementary. And if they are supplementary, that means if I add them together, I should get 180 degrees. There's my equation. This is the defining the variable. This is the writing the equation. The picture counts as defining the variable as far as I'm concerned. So I mean 7x and x, that's 8x plus 25 equals 180. So 8x equals 155. I think that's right. Did I do that right? 7x. Yeah. Sorry for the dead time here. Yeah, I did that right. Okay, 155 divided by 8 means that the angle is 19.375 degrees. And the supplement of that angle, we would just subtract that from 180. So 180 minus 19.375 gives me 160.625 degrees. So again, I just subtracted this one from 180. I also could have multiplied it by 7 and added 25, and that would give me the same answer too. But we need both of those angles as our answer there. Example 6, twice an angle decreased by the complement of the angle is 36. So now we're talking about complementary angles. Remember, complements make things all right. And so my angle is a right angle. And I have 2 angles that combine to form this right angle. Here's one of the angles. It says twice an angle decreased by the complement is 36. So I don't really have a way to define the complement here. Except I could just say, well, these things add up to 90. So if one angle is x, the other one is 90 minus x. So you notice in the last problem, they gave me a way of defining the other angle. They haven't really done that here. What they've done here is given me the equation, right? This is the equation that I'm going to write, but I need a way to define that other angle. Well, they add up to 90. So if one is x, the other one's 90 minus x. Now it says twice an angle. So x is my angle. So twice an angle would be 2x. Decreased by, we're going to subtract the complement of the angle. Now 90 minus x is the complement of the angle. So if I decrease by 90 minus x, that's supposed to be 36, but I did something wrong. Raise your hand if you can see what I did wrong. Now put your hand down because I can't see you raising your hand. Stop it. Okay, so you can just think about What did I do wrong? And the answer is we need parentheses around that 90 minus x. I hope some of you were yelling at me about that. You need parentheses. You're right. There we go. All right, so now I'm just going to solve my equation. I defined a variable and then I wrote an equation. Now we're going to solve it. So I'm going to distribute this negative, or you can think of it as a -1. -1 times 90 is -90. -1 times -x is positive x. There we go. 2x plus x is 3x minus 90 equals 36. I'm going to add 90 to both sides, so that's 126, and x equals 42. It wants the measure of the angle and its complement, so I can just subtract 90 minus 42 and get 48, and there's the complementary angle, because they have to, oh, that's not right. Yeah, it is. Okay. So they have to add up to 90 degrees. There's my two angles. Moving on to the motion problems. All righty. So these motion problems aren't that bad as long as you can get a good idea of what's going on in the problem and a strategy for defining your variable and writing your equation. So let's see what's going on here. A radar detected an unidentified plane flying 5,000 miles away, approaching at a rate of 700 miles per hour. 15 minutes later, a Defender plane is dispatched. It's traveling at 800 miles per hour. We want to know, how long did the interceptor take to reach the approaching plane? Now, what you've got here is this table, and I'm not going to use this table at first. I actually don't like using the tables for these problems. Some people do, though, so I will go through and show you how to do that. But I'm going to go through something else that I think is just as easy at first. So let's just get a picture of what's going on here. Let me put this underneath. Let's just get a picture of what's going on. So here we are. We are in like our little radar station, and 5,000 miles away, there's this airplane coming in, right? So 5,000 miles away, there's this airplane approaching, right? But this whole distance is 5,000 miles. This airplane is approaching at a rate of 700 miles per hour. Okay, here we are. The plane's over here and it's coming at us at 700 miles an hour. 15 minutes go by. It takes us 15 minutes somehow to get a pilot in a plane. I don't know how it took 15 minutes, but eventually we get our own pilot in a plane who starts traveling straight at that other plane to intercept it. The plane that we send out is going 800 miles per hour, okay? Now, the way that my picture looks, it looks like the two planes are going to collide with each other. This is not at all the idea. It's just at some point they're gonna kind of meet each other. They're not gonna fly into each other, okay? Don't worry. No destruction or bad things happening here. Although it seems like this unidentified plane might have some bad intentions. Maybe it doesn't. Maybe there's something else going on here. Okay, so what I have here is I have a distance. I have a rate for each plane. I also have this thing that talks about time. Right, something that talks about time. 15 minutes went by before we dispatched the other plane. Give me just a second here. Okay, so let's set up something that has to do with time here. This whole thing started with this plane flying towards us. Let's say T for time, is the number of minutes that unidentified plane is flying. Now let's think about how many minutes our plane is flying. Well, he took off 15 minutes later, right? So, however long this plane has been flying, this plane's been flying for 15 fewer minutes. So let's call this time T minus 15 minutes. Now, I'll be honest, whether to subtract or add that number there, that 15 in this case, is often the trickiest part of these problems. So you've really got to think through what's going on. Okay, this plane has been flying from the very beginning. By the time these two planes meet, let's say this plane's been going for T minutes, which means the other plane has been traveling for 15 fewer minutes because it took off 15 minutes later. All right, so there we've got a picture of what's going on. I also want you to remember this little formula that you have seen before, that distance is rate times time. And that's going to be important here. Okay, I want you to notice that I have a rate and a time for both of these planes. Let's call this plane A. Let's call this plane B. Let's find the distance for plane B. Well, the distance that the plane has traveled is its rate times its time. Its rate is 700 miles per hour, and we should multiply that by its time. Uh-oh, I might have made a little goof here. My rate is in miles per hour, but my time is in minutes. That's not good. We need our units to all kind of, what word am I looking for? Be the same, I guess. So instead of calling that T minutes, let's call it T hours. Now that also causes a problem over here because I don't want to leave this as 15 anymore. It was T minus 15 when I was doing minutes, but now I want to do hours so that it matches up with miles per hour. Well, just think about what fraction of an hour 15 minutes is. Well, it's a fourth of an hour. So I'm going to change that to T minus a fourth so that now my time is represented in hours. All right, so the distance for plane B is 700 miles per hour times T hours. So 700 T miles. That's the distance for plane B. Let's do the same for plane A. The distance for plane A. That's its rate times its time. So its distance is 800 miles per hour times its time, which is T minus a fourth. So that expression represents how many miles plane A has traveled. Let's look at our diagram here. Notice that this distance plus this distance makes up that total 5,000 miles. So based on this picture, it's kind of evident that I need to take these two distances, add them together, and that should give me 5,000 miles. See how this piece plus this piece should be 5,000 miles. They go to, that's that segment addition that you learned in geometry, okay? So there's the equation that I'm going to solve. I'm going to pause this video for time's sake. I'm going to let you go ahead and solve the video. I'm going to pause this, you solve it, and then all of a sudden it's going to flash and I'm going to have it solved and we can check our answers. Pausing in 3, 2, 1, pause. Okay, and we're back. So here's my answer. And by the way, I realized I had an 8 here instead of an 8,000 or instead of an 800. So hopefully you made that change. If you did, you should have found that T is 3.46 hours. However, the question says, how long did the interceptor take to reach the approaching plane? And T was defined as how long the unidentified plane had been flying. To find how long the interceptor plane had been flying, we need to subtract a fourth of an hour. So I just subtracted 0.25 from that and got an answer of 3.22 hours. Now I want to go to this little table so that you can see how this works. It's good to know how to do this just because it's helpful for a lot of people. So the unidentified plane, the rate is 700 miles an hour. The time, we would define that as t hours. And so the distance is 700 t, because it's rate times time. For the Defender plane, its rate is 800 miles an hour. Its time would be t minus a fourth, for reasons we already talked about. And so the distance is 800 times t minus a fourth. Now what this does is it gives you the two distances right here, but you have to know that you need to add those distances together and set that equal to 5,000, right? That's really the crux of the problem, is knowing to add those distances together and say that they equal 5,000. So let's move on to example 8, and I'll do the table first this time, and then we'll talk about how to set up the problem. So Clayton drove to Mackenzie's house where an Algebra 2 study group is happening. The trip there took him 20 minutes, while the trip home took 5 minutes less since there was less traffic, which allowed him to drive 10 miles an hour faster. How far apart do Mackenzie and Clayton live? So his trip from home to Mackenzie's took him 20 minutes, so the time was 20 minutes. The trip home took 5 minutes less, which means it took 15 minutes, since there was less traffic, which allowed him to drive 10 miles an hour faster. Well, we don't know what his original rate was, so let's just say that's X miles per hour, which means the trip home was 10 miles per hour faster than that. So that means whatever his rate was to begin with, coming home, his rate was 10 more than that. You see why we're adding here to X, because we want that rate to be higher by 10 miles an hour. Now for the distance, we're always just going to multiply rate and time. So X times 20 is 20X. X plus 10 times 15 is 15 times X plus 10. Notice the parentheses there, multiplying 15 by that whole quantity. Now I'm going to tell you that in this case, we are not going to add these distances together. And that's tricky. Like last time we added the distances together, and this time we don't. This is why you really need to draw yourself some kind of diagram of what's going on. So here's Clayton at his house. Here's Mackenzie at her house. He drives to Mackenzie's house. He goes there for his study group, and then he drives back home. Notice the thing about the distances, right? He goes to Mackenzie's house, then he drives home, and he drives home faster. But those distances each time are the same, right? The distance to Mackenzie's house is the same as the distance home. So when we find these two distances, we're not adding them up. We are saying they are equal. This is why you need to draw that picture, or at least take some time to think about what the relationship between these distances is, because this time we're saying they're equal to each other. Okay, pause, solve the equation, and then we'll see you when you get back there. Pausing in 3, 2, 1, pause. Okay, some of you might have been yelling at me on this one because we made a unit issue again. We've got a unit not agreeing with each other because our rate is in miles per hour and our time is in minutes. So let's change those times to hours. 20 minutes is a third of an hour, and 15 minutes is a fourth of an hour, which means instead of 20x, we need to have 1/3 x, and instead of this 15, we need to make that a 1/4. So I'm going to make that change here as well. Instead of 20x, we've got 1/3 x, and instead of 15x, I've got a 1/4 x. There we go. Okay, so if I distribute the 1/4, 1/4 times 10, that's 10/4, which reduces to 5/2. You will notice me using fractions as opposed to decimals. Get used to it. Okay, I need to do 1/3 x minus 1/4 x. If I get common denominators here, 1/3 x is 4/12. I'm subtracting a 1/4 x, which is 3/12. and that equals 5 halves. 4 twelfths minus 3 twelfths is 1/12 x equals 5 halves. And now to solve for x, all I have to do is multiply by 12 on both sides. See, 12 over 2 is 6. 6 times 5 is 30, and there it is. X equals 30. That is his rate when he drove to her house the first time. What we want is how far apart do they live? So I need to know the distance. I can use either of these. That would be 1/3 of x, or 1/3 of 30, which is 10 miles. Okay, sorry for the little unit issue there, but it does illustrate how we need to be careful of that. All right, got a couple minutes to do these last two. Example 9, 2 buses leave the bus depot at 3:15, traveling in opposite directions. So I've got my bus depot here. There's one bus going this way, the other bus going this way. I've got a northbound bus and a southbound bus, so I should have gone like up and down. But let's just say this is the northbound, this is the southbound. The bus headed north averages a speed of 55 miles per hour. So we'll put that as the rate for the northbound bus. The bus headed south is 45 miles per hour. At what time will they be 400 miles apart? Okay, so the combined distance is 400 miles. And it says at what time? So they both start at the same time, they drive away from each other, and then at some time, they will reach a distance of 400 miles apart from each other. So in this case, the time is going to be T hours for both of them. Both buses are in the same place. Then we say ready, set, go. They both start driving away from each other. And then at the same time, they will reach that distance of 400 miles apart. So they're both going to be driving for the same time. So the northbound bus, its distance is 55 T. The southbound bus, its distance is 45 T. So the southbound bus traveled 45 T miles. The northbound bus traveled 55 T miles. Those distances combine to make 400. So in this case, I'm adding them together, and I should get 400. 45 plus 55 is 100 T equals 400. So T equals 4 hours. It says at what time. It doesn't say after how many hours. It says at what time. That means what time will it be on the clock. So they started at 3:15. 4 hours later, it would be 7:15 p.m. There's my final answer. All right. Finally, example 10, Hope runs 2 meters per second faster than Quinn. Okay, let's look at the rates. So let's say Quinn's rate is R meters per second, R for rate. Well, Hope runs 2 meters per second faster than that. So whatever Quinn's rate is, Hope's is 2 meters per second faster than that. If she gives Quinn, who runs at a speed of 10 meters per second, oh, that's why we read the whole problem first. They got us there. We don't even need a variable for this. Got to learn that lesson over and over again. Read the whole question. Quinn runs a speed of 10 meters per second. How fast does Hope run? 2 meters per second faster than that. So 12 meters per second. Oh, that's nice. Okay, she gives Quinn a 20-second head start. So let's say here's Hope, well, they're together, but the starting judge goes 1, 2, 3, ready, set, go. Quinn takes off. He's running for 20 seconds, and then Hope starts running. So let's say the Quinn, his time is T seconds. All right, Quinn takes off. Hope waits for 20 seconds, and then she starts running, and eventually she overtakes him. we want to know how long is that going to take. So however long Quinn runs for, Hope runs for 20 fewer seconds, right? She waits 20 seconds, then she takes off, and eventually she catches up to him. So let's say here's Hope, and here's Quinn. The starting line judge says, ready, set, go. Quinn takes off running. Hope is still starting from the same place, but she waits 20 seconds. She's behind him, but since she runs faster, she eventually catches up to him and overtakes him. Notice that their distances are the same this time. The distance that they run is the same. So Hope's distance is 12 times t minus 20. Quinn's distance is 10 times t, rate times time. And in this time, the distances are the same. So I don't add them up, I set them equal to each other. Okay, so now I'm going to solve this. So if I distribute, that's 12t minus 12 times 20 is 240. I'm going to subtract 10t from both sides. So I'll have 2t on this side, add the 240, and then 240 divided by 2 is 120. That's 120 seconds because t was defined in seconds. But this says how many minutes. So we know we convert seconds into minutes by dividing by 60. So 120 seconds is 2 minutes. And that's my final answer. Okay, we did it. We finished lesson 1-4. I'm not sure where I am on my time right now. I think I'm right where I need to be. So we are going to call it quits for this video. You can now be working on homework assignments for 1 through 4. Go get them. I'll see you at some point back in class. Have a great day. Have a great week. Peace out.